I think if you're a millennial, if you had the you wouldn't download a car commercial blasted into your TV for like 4 years.
Do you remember this, Steve? Do you know
I
what he's
do.
talking about?
Yes.
Okay. Can you refresh my memory? It's probably in here somewhere. What was it?
It was like an anti-music piracy commercial that was like, you wouldn't steal a bike, you wouldn't download a car. And I'm like, yeah, fuck yeah, I would download a car. Like, what are you?
Tonight we welcome back Steve Foote. For those of you joining us for the first time, Steve came on a couple months ago? 1 month ago? I don't remember.
What's time?
What is time? It's a flat circle, right? Steve, unlike us two rubes, is an actual bona fide true game professional, and we like having him on to actually tell us what we're actually doing, so we can. What is the actual expression? Don't know your ass from something or other. There's like all kinds of English expressions about like
From a hole in the ground?
from a hole in the ground. Is that the actual? Is that actual phrasing?
I've certainly
Maybe?
said that out, I've certainly said that out loud before.
Do you know your ass from a hole in the ground? Does that sound correct? Does that ring true?
It does.
Okay.
Honestly, a grotesque image.
I see.
Yeah. But yes, I do.
Yeah.
Well, welcome back, Steve. It's really nice to have you here.
Good to do it again. I have no idea where you guys are at now, but I'm sure it'll be quite different.
Yeah, I was going to say, Jeff, do you want to pull up sort of our current... Do you have the game running?
I would love to get the game running, but VS Code server is having a hard time.
Oof.
Maybe it's EC2 that's having a hard time again. I could back out of this in a sec, but I'm going to give it one more chance. Let me see if I can actually even get to the server.
All right. I blame Amazon. Amazon's probably down. That's, always a safe assumption.
You're applying Occam's razor to the situation here. It's definitely Amazon.
Yeah.
So one of the things that's different now, Steve, is that when I come on stream, just because my computer is slow, I made a thing where it'll actually run our game server and development server on an EC2 instance. And this is what you do when you're a web programmer trying to procrastinate on making a game. you turn everything into a web app of some kind. It looks like that node is. I think this is VS Code now. Which massive monopolistic company am I going to blame next? Start with Amazon. We'll move on to Microsoft.
Seems
We're going to
reasonable.
write down a list. Yeah.
What could possibly go wrong?
Yeah.
But if this doesn't work, let's just do local div and eat the frame rate.
I agree. Okay. Oh, this is promising.
Oh, good. But if it's... Is it running? Can you hit the URL?
Well, I need to actually run on the server.
Right.
Run on, rather, the EC2 instance, the actual server, which I will first pull down the latest stuff. Yes, I do want to trust that key, and then hopefully this should work.
Let's kick it over to programming view. See what you got.
Okay. Wow, there's a lot of pressure.
I know.
So did you basically start an EC2 instance and just jump on the box and set things up, and it just perpetually runs and you work off of it directly now?
Yeah. So this script here basically will provision an EC2 instance, kind of wire some things up SSH wise, so it's easy for other programs that are running on my computer to talk to that box. So it does like a port forward and some like agent forwarding and all this kind of like fancy stuff. And then if I terminate this tab or this program, it'll terminate the EC2 instance, so we're not paying for it.
Right.
Which on the job, at least, I've done many, many times.
I care a lot less when it's not my money.
Yeah, exactly. Yeah, I'm kind of emotionally a little bit less involved. Yeah, hire me.
What?
That's the level of service I'll provide for you.
Definitely what I do when I do my experiments, where I have a bunch of alerts on my AWS account, and it'll be like, I got charged 20 cents. Like, what did I do? And it's like, oh, you left an IP address dangling or something for 4 hours.
Is it? It is port 3000, is it not?
Port 3000.
Well, it's not working.
Do you want to try
It's not
your
working.
You want to try your host name? I see the remote host name there. If you want to Just hit it.
We could try that.
Yeah.
All of this stuff was fine.
Before I like pushed a tiny change. Yeah.
Yeah, what's up? I think
running this.
EC2 is having a weird time.
All right.
I'm gonna run this locally.
Yeah, local dev.
This makes me sad, but okay.
It's the
Well, at least
truth.
I know it terminated the instance because VS Code just immediately got booted off.
I'm sorry. I had such a good like programming day today that I must have used all our good tech karma. It's my fault. My
The thing is,
bad.
none of this should have changed, really.
No, I know.
Like that's the funny thing about all this stuff. It's like nothing has changed. Everything is like a snapshotted image.
I ran this shit last night. Yeah, it should be fine.
Yeah. I wonder if I messed it up by doing incremental build. Did I even run the game?
Oh, Jeff. Now I don't know.
Because I added incremental build yesterday. All right. Something is slow about my computer right now. I'm going to say that we've got gremlins tonight, so we'll see how this goes.
All right.
Steve, how's your 2021 going?
Not too bad so far. Like feels we had like a crazy over the holiday release because of new laws going into effect in the EU for payments that we didn't know about. So coming into the new year, not having to do something crazy fire drilly, it actually feels like kind of chill. For some reason, my calendar has like no meetings on it, so I've been engineering the last week. It's kind of nice.
Oh wow, amazing!
Nice.
But yeah, not too bad. Other, trying to not check the news too much, but
Yep.
Yeah.
That's
it can't be helped.
that's
Yeah.
for real. Yeah. Hey, that's a game.
This is a game, so we finally got it running again. So this is going to look a little bit different than you saw it last time. I think multiplayer still works, although we haven't really tried in a while. So we'll
I've
see.
been mostly doing single player. So this is much more 3D than before.
Yeah, it's a bit more 3D than before. And I think last time you had expressed that you felt more in your comfort zone talking about 3D stuff. So we figured it'd be fun to bring you on once we had some toehold into the world of 3D graphics. I will stress the word toehold. It's a very tenuous grip that we have right now, but it's about to get a whole lot better after tonight.
And I imagine this is all like WebGL and I think in one of the other Discords you were asking about OBJ files and things like that. So
Yeah.
Let's say welcome back to chat, Dean Putney. 10-4,
Nice.
10-4, good
Hey,
buddy.
Dean.
Says we're having some extremely productive game development time over here, which we are.
Yeah. Gosh, this is slow. I did order my
I was gonna say, when's your M1 get here?
my new MacBook Air, and it'll be better. Part of the reason why I wanted to run this stuff on an EC2 instance is that I have too many things running on my computer right now. But at any rate, we are kind of 3D now. Most of the game logic is exactly as it was before, but as disciplined programmers, we were able to separate it out from the rendering layer. I don't know if that's 100% true though, because we had to pull out a lot of wires.
It's largely true. It's still a 2D game. It just happens to have a nice coat of paint on it right now.
Yeah. So I think broadly the topic that we'd like to talk about is like how one should actually organize a 3D rendering pipeline in a video game.
okay.
But maybe the right way to go about it is to just walk through how we're doing it right now, and go from there.
Okay.
So we are using WebGL. That is a technology that I'm not sure is representative of how video game graphics engines get written these days, right? That particular API is, I think, been out of style for a while. Is that right? Like an OpenGL ES style API?
I mean, it still gets used, but it's definitely falling out of favor, especially with Apple's Metal stance. kind of pushing OpenGL off to the side. Obviously, you can still kind of use it, but
Right.
There's definitely movement towards Vulkan, DirectX, kind of metal.
Right.
And what OpenGL, other than deprecation on Macs, is still going to get you the most platforms. But
Yeah. Well, cool. If there's time, probably towards the end of the stream, it'd be awesome to hear about what those newer APIs look like. Because on this stream, we've been to learnvulkan.com, and I believe there's actually no content there right now.
Yeah, Vulkan is. Yeah, I don't know what's going on there.
yeah, we can definitely talk about that later. Vulkan's a beast. I've done some prototypes in it. Obviously, day-to-day job, we end up using some engine. In our case right now, Unity. So you don't necessarily touch that stuff, but I have delved into it just to dip the toes and make sure I don't lose that low-level stuff. But it's a beast. It's not as easy for sure.
So I think Dom and I had actually talked a little bit before stream, and the kind of like large question that we run into when we're doing 3D graphics is that and I'm sure this doesn't change between OpenGL and WebGL or Direct3D or Vulkan or whatever. You just have lots of renderer state, lots of individual functions that can flip these different switches on how you want the rendering to behave. Lots of opportunities to preload data into the graphics API, and all kind of opaquely getting shoveled around between main memory and GPU memory.
Right.
And it's kind of hard to know from a performance perspective how one should be grouping all of that switch flipping,
Right.
And so what you're about to see, so this is all essentially me putting up sandbags, because you're about to see our kind of first crack. It's like me and my buddy's first 3D engine. So I'm really just trying to set your expectations here. Cool. Dom, where should we start? What's the right way to introduce our graphics pipeline?
Let's see. I guess maybe we could start with our model loader.
Oh yeah, totally.
Talk about GLTF for a second.
Yeah, so we are in this is a kind of game engine in transition where we started with a bunch of OBJs. But we quickly realized that OBJs as a format have no notion of mesh hierarchies, right? You basically just have the geometry kind of splatted at you. But you don't really have a notion of one piece of that 3D model being subordinate to another, right? And that was important just because we wanted to be able to animate things, right?
Okay.
So this little tank guy, we kind of grabbed him from what was the name of the site again?
Dude, it was cool3dgraphics.com or something.
Cool3dtanks.com.
It was extremely sketch. Yeah.
CG Trader, was that what it was?
CG Trader, thank you. That's where cool graphics came into my head.
Yeah. This was the best low poly tank model we could find. And we picked an appropriately kind of army men style green for this. Because right now the thing, our engine can only draw one color for every object right now.
Okay, but you have some notion of lighting, it would appear.
Yeah, we do have. It's very good. This is a true graphics professional talking right now. You can see, he can tell those
some
kinds
notion.
of some details. Yeah. So
I don't want to say lighting because I don't know if the some notion is actually accurate.
It is lit,
Okay.
both in the mathematical and figurative sense of the word. So we have OBJs in here, but we also have started to move to a format called GLTF. Are you familiar with that?
I have read some of the docs. I've never used it myself.
Yeah. It's basically a JSON, a big JSON blob that describes a whole scene hierarchy, and then also optionally can contain the actual buffer data for index buffers and vertices. I think it can even include textures. We haven't gotten quite as far as texturing, but yeah.
Okay. I think that's actually a pretty good choice based on looking at formats. If I was going to start, engine from scratch, I would probably consider that at this point. FBX is still an option, but that SDK is pretty something. And yeah, it's a lot of bloat and proprietary. So,
What is FBX?
That's kind of the Autodesk family of things that a bunch of people implement at this point.
Oh, interesting. Film box. Huh.
Yeah. So a bunch of engines will import that at this point. And they do have an SDK, but it's pretty heavyweight. For really what you need is you want something more game specific. The GLTF parts where it'll, export binary chunks for certain things is super compelling. And yeah, structurally it looked pretty good. So I'm curious how it works out for you.
Yeah. And the big switch was that GLTF does have a sense of a node hierarchy, so we could actually kind of like move one piece of a model independent of the other, and still have it kind of like look like something.
Yeah, it's gonna be our very primitive animation system down the line.
Okay.
Yeah, our model, what is it? Models index. That's probably the one we want to look at.
That sounds right. Yeah.
I don't know how interesting this one is actually. Get model pulls. This is actually kind of like our OBJ parser.
Oh, yeah, the OBJ stuff. Yeah.
Yeah.
We don't really parse GLTF because it is actually a JSON format, and so it's kind of natural to web contexts, right?
Okay, yeah, you just
load it in, and it's a JavaScript object as it is, right?
Makes sense.
So what we do is we take that document, which is pretty much just close to its like flat file form, like this just structured string basically, and then we throw it into our renderer, right? So I guess maybe we're gonna end up spending a lot of time in this file. Right? Speaking just about the GLTF stuff, load GLTF? What do we call this? Yes, nice. What we do is GLTF has a notion of like having like a series of scenes in it. Right now, every single one of our GLTF files, I think we have a grand total of 1 right now. It's just the tank.
2. The turret is also GLTF.
The turret is also GLTF. Amazing. Do the turrets rotate?
Yeah, I snuck that in there.
Oh, dude.
Yeah, they aim at you.
Oh my god. Incredible.
Yeah,
These little debug draw trails makes me really want to get a particle emitter going again.
Man, honestly, some of our debug stuff is like more aesthetic than the actual graphics we put in here.
Exactly. So we have a GLTF loader. Once you run into a node, I think, long story short, basically what this is doing is it's loading like what we call a model. And a model is a tree of meshes. And a mesh is kind of what you think it would be. Do I have the mesh definition here? Let's see. Yeah. So a mesh is a thing that looks like this. It's got basically 3 buffers: positions, normals, and indices. We don't have too many different attributes for the shaders yet. It's just really pretty basic right now. Right now, anything that's color related is basically set as a uniform for the fragment shader. So what a buffer is really just kind of like a buffer index. If you were to call like GL create buffer, we get something back, we bind the data. So basically when we load the model from the GLTF document, we go ahead and like bind our stuff to a buffer. And so this is actually an earlier iteration of this engine. We'd actually just keep a VAO floating around, and that would have all the buffers attached to it. And so when we would switch models to render them, we would just say, okay, this is the VAO we currently want. But I didn't do that this time around because of reasons that we'll get into in a second.
Okay.
Yeah. There are this buffer object here actually has some extra crap attached to it to basically say that, we may need to interpret the buffer because the memory layout is a little bit different. Maybe it's not floats or something like that. Yeah. So that's the data format that we're dealing with right now. And so by the time that we're actually storing one of these meshes, we've already like told WebGL, hey, here's like a buffer of binary data. You load it, give me back a number, and I'll hold on to that number, and I'll tell you when I want to draw it. Right.
Okay.
Cool. All right. So we do have some notion of, I don't know if render passes is the right thing, but we do have different groups of things that get drawn in different ways. So I think right now we're looking at three main categories. We've got the stuff that uses the old OBJ style rendering. I guess I won't dive too much into that. We've got the GLTF render, which is the turret and the tank. And then we have also all this debug draw stuff, all this wireframe stuff that's also getting drawn. And we kind of draw those in three separate phases. Is it the render manager? Yes. So let's see. This is the old render that does all of our OBJ stuff. We iterate over a bunch of models that we have. They have positions attached to them, and then we identify the model by this model ID, which is just a string. So the renderer class that we created has essentially like a key value table of like models in it. You just give it a name, give it a string, and then like it'll have the model that we loaded in there. And then this render v2 pass is the GLTF stuff, and then we have like a render wire pass isn't necessarily quite the right word. I'm not sure what the right lingo is, but basically we have groups of things that we render with kind of different overall settings, right? The way that it lines up currently is actually render standard, render v2, and render wire are actually three different shaders. The shader programs are all very, very similar to each other, but they are different in kind of small ways. And so basically the main grouping right now when we do rendering is basically by what shader is currently loaded.
Okay.
Yeah. Is this so far sounding relatively accurate?
Yep. Yeah, you're on it. Yeah, I think, and one of the things that has definitely been a question in my mind is Dean's on CG Trader looking for a new model for us.
We saw some pretty rad like Gundam looking things for like not that much money. It was like $100, right?
Well, I mean, I think
you get a sweet Gundam for like $100.
He says, does it have to be a tank? Like, we're down for cyberpunk. So and we might turn it into a wireframe. That's our like plan, future aesthetic. So think what'll look good in wireframe down the line.
Yeah.
But this actually raises a question for me. Like, if we were to put a big expensive model in here, like each one of our draw model calls is sort of like an individual like splat of a cube or a tank one at a time to the GPU. Like, are we doing it right?
Yeah, I mean, we can dive into the actual kind of like granular details of what's going on here. So let's look at the like, this is, I think, structurally the way a lot of things work. Well, first of all, like all three of these like different kind of go back to the render manager really quickly. All three of these end up using the same camera position because they're basically all like, they're all being drawn from the same perspective. Right. So we do actually tell the render like pretty early on, like here is the world to view transform that you should be using. And it comes from our camera. And then we render everything based on that. So I guess we'll kind of get into like essentially just like what are the GL functions we're calling at like at what point. So for the GLTF stuff, we flip on like we sort of just like call all of these functions with different parameters for every single one of these different render stages that we do, just because like we want to make sure that like they clear out the previous state, right?
Right, and you just call that at the top of your block and leave it until you're done.
Yeah. So we've got the Z buffer enabled. We've got backface calling enabled. I just learned that you need to like actually turn on alpha blending.
Yep.
It's so funny. For like weeks and weeks, we were like Gosh, like we're setting alpha values, like it's not blending at all. Why is that the case?
Whoops. Yeah.
Yeah.
Dean is going hard in chat and wants us to put a Shiba Inu in here, and he's not wrong. This
A
could
Shiba
be
Inu.
this could be a dog instead of a tank.
Oh, dude.
It's a whole new game.
Well, if we put the dog in there, we're gonna have to make a pet mechanic, right? Like you have to be able to pet the dog.
Yeah, I'm gonna make a build for him later with just dog in there because I'm excited.
What does it look like if a tank pets a dog?
Can a tank pet a dog?
You know what
the turret just goes and goes like pat pat pat.
No, there's a version of this game like 50,000 commits ago where you could like send the little guy out and he would harvest trees and he could actually build walls and stuff.
It was like
that was when we were actually.
RTS.
Yeah, no, I mean that's what we're going for, right? Is that's actually kind of what we want to be able to do is to like RTS plus driving around shooting things. And back when we were actually making a game and not a student 3D graphics project, you know, like. We had a guy that could run around. And so if we're going to pet a dog, we would just send the guy out and he would run out and pet a dog. Oh, but now that it's 3D, we could like zoom in because the guy is like way smaller than the tank. And presumably the dog way smaller than the guy. Or the dog is just giant, right? It's the size of the tank. And then the guy runs out and pets a giant dog. You're not feeling me here, Dom. Like you're.
No, sorry. I'm explaining. Dean was like less military industrial complex. I'm engaging with chat, which is a new thing for the stream.
No, that's totally. How's it going, Dean? Good to see you.
But no, he said less military industrial complex. So I was explaining that our original conception is that you steal a police tank, and have a revolution, overthrowing the state forces.
Yeah.
Which I just typed in chat, but also he heard me say out loud.
What you don't announce everything that you type. You don't say everything that you type out loud. I do it when there's nobody in the room. It's just it just soothes me. Okay, so I'm curious, Steve. Have you ever seen anybody use any other parameters for the alpha blending besides the ones that you see here?
You do.
Tell me more.
A lot of it is like in VFX or things like that, right? Where
okay, right.
You're wanting to overlay in a way that's not just like, you know, whatever Photoshop opacity, right?
Right, I see. It just seems cumbersome, given the amount of flexibility that you have in something like, say, a pixel shader or whatever. It seems kind of weird that you sort of like tune the colors this way. It's like I'm gonna use these enums that like.
Yeah. So I mean, not to digress too much, but there's rationale and history to that, and probably someday, eventually, it won't be that way, right?
How much is rationale and how much is history? Do you catch my meaning?
Well, okay, so back when 3D cards first started, right? Yeah. Most of it was a fixed function, right? Where you could specify some verts in a couple settings and say go. Even like the original pixel shaders were a lot of that, where you could like switch different things around. Like I think even on when you were doing games on the Wii, you were basically configuring your pixel shader. It wasn't a shader because you couldn't actually program it, right? Like shader program, pixel program. It wasn't really programmable. It's just like a bunch of enums where you're like, I want to take these two textures and do some math op. That's some enum that I pass in. Normal maps, things like that were that way initially. And that's because, you know, trying to get this hardware to mash as much stuff through as possible is this fixed function thing, right? You know, like eventually you start adding more programmable bits, but to get all these verts streaming through as quickly as possible and the pixels streaming through as quickly as possible, certain parts are still fixed function, right?
Yeah. Because
I can have a triangle rendering in a mesh and then another triangle rendering, and they're happening on different, you know, cores or threads or whatever terminology you want, wavefront, you know, if you're, depending on which graphics card you're on, right?
Mm-hmm. So wavefront, that's very fancy.
I think that's right. Wavelets, wavefronts, something like that. So what is going to reconcile those two things and do that blind logic operation, right?
Right. it can't be your shader at that point, right? Or
right. So,
yeah.
so if you want that fully programmable, then you need something that can take in probably multiple inputs over time. Like this pixel is going to resolve after this one, or the fragment, right? Because fragments are the potential pixels. Which order are those going to happen in? So those end up kind of driving into like a fragment processing queue that will do a bunch of stuff to order it and like spit out the final color and like write it out to the buffer.
Right.
So if you let people do whatever they want in there, you're going to probably incur some amount of performance penalty.
Right.
By allowing that flexibility. So to keep it fast, they don't allow that flexibility. So it's just a bunch of, flips and switches and stuff to get stuff through.
Right.
It's the same reason that there is some structure around the primitives that you're going to spit out, like how stuff gets into the vertex shader.
Yeah.
Even though based on how the GPUs are structured, if you're doing a compute shader, you can just, hey, I want to go bind a bunch of buffers and pull things in and do some arbitrary math and spit out some new buffers.
Right.
You could foresee a world where you make more and more programmable, and it gets closer to just this crazily parallel thing that you're basically doing software rendering on again.
Right.
And you could do that. Like if you're like, I'm going to get rid of the fixed function stuff, write a bunch of compute shaders and do some special rasterization out to a buffer. Like you could do that. It'd just be a lot slower.
Yeah. That evolution is kind of interesting because it feels like we've moved progressively in that second direction that you've talked about over time. But I remember when you and I were working on, let's say, the Nintendo DS, right, where the graphics hardware basically was just like a ton of registers that you would set, you set bits on and say like, I want you to do this right now. I want you to have this, exhibit this behavior. And then you filled some graphics memory and then let it render. But now we're kind of getting in the state where like big pieces of the rendering are now customizable down to like, I mean, we're basically we're compiling programs and moving it over to the GPU, right?
Yeah.
Yeah.
Which is pretty interesting. I mean, it's kind of why I think the programming for something like DS is actually pretty enjoyable because like this spot in memory, like right here is like the X coordinate of sprite number 2, like always and forever.
Right.
Which is interesting. Like, I don't think the official SDKs had it, but I did some like GBA homebrew, and the SDK was just a bunch of like pound defines for memory locations. Like they weren't API calls or anything. They're just like this spot in memory does this thing, write to it, flip some bits, you're done.
Right.
So definitely pretty different. Like the amount of stuff between you and a GPU is a lot, right? All these drivers and like the thing I've heard as kind of describing the weird complexity there is if you take a GPU, like NVIDIA GPU, and install it like on a Linux box or a Windows box, or if you install, Apple puts the same thing in their thing, you're writing in a different shading language, right?
Yeah.
Because they don't let you run the code arbitrarily, even though they're going to, down compile it to whatever thing that NVIDIA GPU actually runs.
Right.
So very, very different than DS programming, but, DS can't do that much.
Okay. Could probably talk a ton about that sort of contrast between different like graphics programming styles, but just for the sake of time, we're going to carry on with this implementation. So what we're doing with actually drawing a particular model, like the interface for this function is a little bit complicated, but suffice to say that each time we draw a single model, we're essentially passing in the name of the model, because again, the renderer just keeps a database of all the things that have been loaded already. We're passing in what we called model modifiers. These are basically like string identifiers of individual meshes inside of a model. So we're presuming essentially that the client a priori already knows like how the model is structured. So basically we can apply a transform matrix to like the local transform of that mesh relative to its parent in the node tree.
Okay.
We
That's
kind of
interesting.
explicitly wanted to avoid doing keyframe animation because I didn't want to like slurp anything up front. It just seemed like a huge distraction. And so basically to rotate the tank turret right now, we're just like saying, okay, like the second child of the first child of the 0th node, I would just set a rotation value of this much. That's basically what we're doing right now.
I mean, that seems perfectly fine
Yeah.
for that sort of thing, right?
Yeah. We'll see if we need to do more complex animation at that point. But basically, we're not using any animation that's provided externally, where everything is just like a parameter that we're setting programmatically. And then, as I said before, all of our shaders right now, like our only notion of color is just coming from a uniform right now.
Though we've been, I mean, a lot of our investigation for the last week and a half has been what we can do with shaders, and how much of our aesthetic we can accomplish with shaders versus textures, which, we'll probably get to in a second.
Yeah. So to actually draw a model, or what we do is we look up the model that was provided to us in the function arguments, and then that model is essentially just like a tree structure, and then we walk down the tree, each from the GLTF data, each node in the hierarchy has a local transform that is like a transform that's stacked on basically a matrix. Do they express it as a matrix? I think it is a matrix, right, Dom? It's not like translation, rotation, and scale separately, right?
No, we're doing we do a matrix just from rotation, but we could do anything, yeah.
Okay, so maybe they do keep it separate.
We're doing mat 4 from rotation, but like we're spitting a mat 4 in there.
Yeah, model modifiers. This is a matrix that we're looking at, right? This is like 60 numbers. TypeScript doesn't do so well with name. Like the types are all considered to be structural. So like if you describe a type as having like 2 booleans, one called X and one called Y, then it is equivalent to another type you declare that has the exact same structure. So internally, the type checker just like compares structures and not names, which I believe is quite different to most other languages that are statically typed.
Yeah, that's pretty interesting. I didn't know that.
It's really good for like a gradually typed language. Like you have a code base that used to be totally dynamic, and you're trying to gradually move stuff over into a type discipline. It's really nice to have that level of, what would you say? Like it's like that level of flexibility.
Yeah, though I wish I could turn on a strict mode, because man, sometimes I really wish it did not do that.
Yeah, well, we've had to like hack in, like even in this game, we sort of like had to hack ways of just saying like, even though this type alias is just a string, we want to make sure that you can't just pass any arbitrary string for that type. So we've sort of gone through all these contortions to say like, well, this is actually just a string under the hood, but it has to come from this particular function, right? It has to come from a particular library or something like that. What we do to render the model, though, is basically we sort of just traverse this structure recursively. So there's this like render node function on the renderer that itself calls render node on the children of the current node. And so as we're drawing this stuff, we sort of set up the matrices to transform this object. And then we're doing all the matrix multiplication and transformation in the CPU, which I gather is just what you have to do. We don't do any caching over this right now. And then we actually render the mesh, right? And so what we pass in there is a mesh, which is basically a property of the current node that we're on inside the model. The whatever transform matrix that we've accumulated from all the way up from like basically the position of the object in the world to its local transform, anything that was defined in the GLTF file through the entire hierarchy. And then we pass in the color, which came from that original draw call from the user code. And then to render a mesh, I think we're getting back into OpenGL land, right? Mm-hmm. And so we are basically now pulling input locations off of the shader program. Mm-hmm. So this isn't actually making the OpenGL call because we cache this information when we loaded the shader, like when we compiled the shader and linked it, like we basically pulled out all of the locations of the uniforms and the attributes. So this is just like looking it up in a local in-memory kind of key value map. And for this particular shader, we've got the uniform that defines its world position. We've got a uniform for the color. And then we have the two vertex attributes, which are the position and the normal, which come from the mesh. So we go ahead and just start to set that stuff up. So the reason why we're storing like GL buffers and not GL VAOs in the mesh object is that I thought we might want to render the same model with different shaders. And the tricky thing is that the shader, like the positions of the uniforms and attributes might vary between different shaders, right? So that was kind of the philosophy behind this. So here we actually just kind of generate the VAO on the fly and then bind our position and normal buffers to the attribute locations that are specified for this particular shader, right? Is everything kind of making sense so far?
Yeah, that definitely makes sense. I mean, it's pretty standard way of doing this stuff, right? If you're like, I'm not optimizing performance, you're probably gonna like, whatever, I'll just set it to keep things simple.
Right.
That would start to change if you're trying to get optimal performance out of it.
Right. Right. Well, I'm going to bookmark that in my mind because I think eventually we might be trying to get optimal performance out of it.
Yeah. Though honestly, it's shocking that the switch from 2D to 3D has actually vastly improved our performance. I think just because it's taking stuff off the CPU.
Yeah. I don't know how the 2D rendering API is implemented for the web canvas protocol, but it seems like the game got faster when we went to 3D.
It really did. Yeah.
Yeah.
Without, I guess, showing my bias against web programming, that doesn't surprise me, right? Like,
yeah.
Websites aren't exactly the snappiest thing ever versus just getting things to the GPU in a good way, which is, like old style OpenGL ES isn't exactly the most modern API, but it can be a lot more modern than Canvas, I think.
Yeah. Well, it's not like we could have done the 2D version with the DOM, right? Like we could have just like made a bunch of HTML and animated the HTML, right? By like animating CSS properties, right?
Right, which would probably be even slower than Canvas.
People actually make games that way, right? People.
Oh, I'm sure. Yeah. Absolutely.
Yeah.
Absolutely.
Yeah. But yeah, I think essentially what we had before with the 2D stuff was kind of like more of a traditional like pen or path oriented 2D drawing API, which I'm sure is all being calculated on the CPU ? I don't know. I think there might be ways of GPU accelerating that stuff, but I think that was probably all just like straight on the CPU. Okay. Last thing, we bind the index buffer, and like basically at this point we're ready to go. We just say, okay, just draw it, right? Shoot it off. And then here, I actually just delete the VAO that I just created. I actually kind of don't know the garbage collection or whatever. Like, there's a lot of this that's just not very well documented, but I figured just for the sake of cleanliness that I would just delete that VAO. So before we dive any deeper, one thing I want to make clear, I think I kind of know the answer to this question, but I just want to confirm with you, Steve. Like, when we make these function calls into our GL context, nothing is actually happening at that time, right? This is just kind of like in queuing something somewhere to be done later.
I mean, you're talking about like each individual GL call, right?
Yeah, exactly. Yeah.
Yeah, I mean, there's a lot that happens between that and something actually happening on the GPU, right?
Yes.
Depending on the driver. I mean, that's probably where a lot of like the graphics bugs come in, right?
Yeah.
Some driver trying to do some comparison caching thing so that if you haven't changed information, it's not actually gonna, send that over to the GPU because now you're, sending it to a completely different chip.
Right.
So there's a lot that happens there, and eventually you'll hit a point where it's going to start sending it over. there are some points that are like basically hard stops that are just like flush the entire GL queue out and get that to the GPU and then wait for all of that to finish. But yeah, everything in here, you're basically like building up that queue, and then eventually something, whether, hey, the queue's too big, so it's going to send it over, or you're going to do a call that's kind of one of the more blocking ones that like flushes it out.
Yeah. It's so interesting that driver almost kind of like undersells the software engineering project that it's actually describing. Like it's almost more like an operating system at that level. It's just got to be so complicated, right?
Right, and that's, I mean, without going into it, that's what makes Vulkan harder, right? Is it basically removes that layer.
Oh, interesting.
Right.
Yeah.
Yeah.
And now it's on the programmer again, which for game programmer, or at least engine programmers, like, great, like the stupid slow driver got out of the way, and now we can do like even closer to the metal, which isn't quite as close as you get on a console, but a lot closer, right? But people who don't care about that are like, why did you make Vulkan? This is too hard. This is dumb.
Yeah. So at the risk of getting too far off topic, like I'm curious about that. Like, do you think, like, in terms of like the ecosystem of graphics technology that is exposed to programmers, like it feels like we're almost going in two different directions, where on the one hand, as you're saying with Vulkan, like the graphics APIs are getting more and more low level. On the other hand, like the way that people are implementing games and stuff are using like the highest level thing, which is like a pre-baked engine with the level editor like tacked on it, right? Something like a Unity or a Godot or whatever. Do you think that something will reemerge on top of Vulkan or Metal or whatever that will be kind of like the replacement old school OpenGL, or is that layer just going to go away completely?
I think there'll probably be something like that.
Yeah.
I mean, I wouldn't be surprised if some manufacturers like writing a OpenGL emulator on top of Vulkan at some point.
Exactly. Yeah. They just re-implement OpenGL on top of Vulkan, right? Yeah. But I think probably the exciting thing about that is that it would open the space up for doing something that was like, I don't know. I have this impression in my head that Direct3D for a long time was like easier to work with than OpenGL. Is that a fair statement to make?
To do things based on how GPUs worked, OpenGL was in a pretty weird state for a while. So during that time, I would say that's probably true. Where when like OpenGL existed before GPUs, right?
Right.
Whatever weird like OpenGL SGI something, right? There was driving some other weird thing, right? So it wasn't based on that modern like NVIDIA kind of AMD push of graphics technology. So it kind of, like the GL approval committee was super dragging their feet for a long time. So it ended up being a lot of like extensions or weird kludgy things around the driver to kind of make it work, and it wasn't in a good state for a while.
Right.
And then they kind of caught up with, what is it, like OpenGL 3 or something like that. I forget the exact one, but when they started kind of aligning a little bit better, and then ES in some ways is actually an improvement on the other stuff. But at this point, DirectX still probably gets updated faster because one company. But
the example I'll give is that like Dom and I actually spent like a whole stream and a half maybe using a website called WebGL2fundamentals.com or something like that.
That site was great.
And it had this OpenGL or WebGL state visualizer. So it unfortunately didn't allow you to paste in your own code, but it basically had a lot of great examples. Like how do you render like a 3D cube with textures and lighting, and the textures themselves are rendered from something else,
Right.
And it actually showed you all the different like driver constructs that were getting populated. That was actually most of the view of the web page. I think a key example of that is like just trying to figure out like what the fuck is like bind buffer with this first argument in here? Like, it turns out that there is a slot on the currently loaded VAO called the array buffer slot that you say, like, I'm going to bind that to this other buffer object. And then I'm going to like set some properties on. So even just like getting that kind of like idea in our head, like if we were just left to reading the official documentation, we would have no idea what the hell is going on. Right.
Yeah. I mean, it's like, if you haven't done it before, the documentation is hard, and then like debugging this stuff is annoying. It's why a bunch of game programmers hate graphics programming still, right?
Right.
You're like, okay, cool. I did a bunch of stuff. I sent it to the driver, and what do I get out the other side? Like an empty blank window.
Yeah,
like,
it's a giant magenta rectangle. That's
well,
what it is.
Like if you're lucky, you're like, did it even draw? Let me change it to magenta. It's still black. I get, like, I don't know.
Right. And so the thing with OpenGL here is it's really hard. Like, I think what we're essentially doing here is like reinventing a programming language, right? We've got like every API for any library is ultimately kind of its own DSL, and every DSL is just a shitty programming language. And I think OpenGL, like in my experience or the experience of the past few months, has been like, it's just kind of particularly hostile and non-ergonomic. And where I was going with this whole, like, can you re-implement something that's like OpenGL or old school Direct3D over Vulkan is like, somebody could make a new standard that's a little bit easier to understand, right? Somebody could do it, and it would be, and you could make it non-proprietary, right? You could make it open, and that would be really cool.
That'd be interesting. The use case would be probably suspect at the end of the day, because people like me are like, well, it's now easy because I can't do the things I need to do, and then everyone else is still using Unity, right?
Right.
So.
Right. So that was what I was kind of talking about, though, is like basically, is there any argument for the middle ground anymore, or are people just either left to like being like 1,000 miles away from what's going on by like working in the Unity space, or do they have to just like dive right into it and just like learn Vulkan, So
I think the thing that would probably have the most merit is making it easier for people to learn the fundamentals, right? Like the slightly higher level fundamentals, so that you understand an engine more than just being someone who uses Unity.
Yeah.
But without the learning curve of the complexity of someone who's trying to make Unity.
Yeah. Yeah. But I can imagine that being like almost distractingly difficult, right? Because like what the driver is doing for me right now is like there's some DMA that's happening right now between like my buffers that are sitting in main memory and then like it going into GPU memory, right? And then like there's all this kind of stuff that's like timing related. Basically what we're looking at is like a distributed system, right? It's an asynchronous program, and like if I didn't have OpenGL doing that for me and I had to do that myself, it would feel like incredibly tedious. Like it would feel incredibly like how long would it take me to get even the black screen drawing, Right.
I mean, I think educationally you probably, like, I don't know if you've seen, what's it, like Pico 8, where it's like a little,
I love Pico 8.
The fake system that's easy to program, right? I feel like there's probably something like that for 3D, right? Where you're like, it lets you kind of start learning the fundamentals of 3D, and it's really an emulated system. It's nowhere near as fast as a real thing, but that's not the purpose of it.
Yeah. Okay, so we've just walked through, I think, what is basically our entire rendering pipeline. All the other rendering stages that I talked about, like the wire render, which is what our debug draws is kind of like drawing in. I mean, it's essentially exactly the same thing, but the parameters are a little bit different, right? One of the things that we do in the wireframe stuff is that we have the ability to change the depth function, because I wanted to be able to like draw wireframes on top of something that was already shaded, right? So like, so I use like a less than or equal to right here, so I can like kind of draw something on top of a surface. Other than that, I mean, like it can also handle like different primitives, because I wanted to be like I have some models in here that are like I don't even know what they are, but like I wanted to also be able to like draw lines, right, in debug draw. So I have like a line primitive drawing that I can do, but it's essentially exactly the same model. that we were talking about before.
Okay. So you're generating those somewhere, like some debug lines generation function.
Yeah. So if we're doing lines in particular, the lines are essentially pairs of points. I just kind of like I create a VAO on the fly, and then I basically write the position attributes on the fly into a new buffer. Do I create a buffer here? I think I do. I guess technically I could just keep this buffer around and like replace the memory on top of it. But I don't. Again, like because so much of this is abstracted away, I don't know what's free and I don't know what's like not free. You know,
It's a bummer that half of the question is what is JavaScript doing too?
yeah.
Right. So wait. So is this per line, or do you do a bunch of lines at once?
This is a bunch of lines at once.
Okay.
This is per lines that are the same color, right? Because the color is, I think, a uniform in this case.
Okay.
Yeah.
So like that, the entire grid is one draw call.
Yeah, actually, the entire grid, the grid is actually technically a model that we don't reconstruct every frame because it's big enough and static enough. But something like this red line here, that's kind of like showing you where in world space the mouse cursor is, that's being reconstructed every frame because the positions are changing every frame.
Okay. What about like the purple under the trees? Is that static from the beginning, or is that per frame as well?
That one is static from the beginning. I think it's literally a model that's just 4 lines. Yeah.
Okay. So each one is an additional draw call to each tree, which is a single draw call as well.
Correct. Yeah.
Okay.
Anyways, so the question that I think we're sort of drilling towards in the way that we're talking about this. Are you guys still with me? Sorry, the video froze for a second.
Oh yeah, we here.
Still here.
Okay. The question that we're kind of drilling towards, and I think it's actually related to like your line of questioning, Steve, is like, what's the general way of organizing this stuff, right? Like how do you we don't even have like lighting, so we're not like grouping things by lights or anything like that. But like there's all these functions that we're calling in OpenGL, and like there's also like some amount of like pre-creation of buffers and keeping them around, references to them around. Like, what's the right way to be organizing this?
I mean, so if performance was your number one concern, right?
Yeah.
Basically, the goal at the end of the day is to keep as much on the GPU statically, like we're not updating it as possible.
Yeah.
And to make as few draw calls as possible, right?
Right.
That's a lot of it. I mean, obviously there's the nuance of shaders and things. So like as far as how you structure, there's kind of and some of this comes down to doing performance checks on your individual hardware, but there is kind of a notion of what is the most expensive thing to swap, right? So for example, like swapping blend modes or things like that can end up being pretty expensive on some hardware, potentially most hardware, because now those pixels in flight are going to need to basically resolve what they're doing so that the next ones through the fixed function are consistent, right? Yeah. So there's like flush points, and those ones end up being expensive. Like some,
it's like a fence. You have to make sure that like basically, because we now have to handle everything differently after this point. Like you have to kind of stop the world, let all the previous things draw first, and then change that parameter and let everything else draw in the new mode. Yeah.
So that's kind of the worst case, and some of those flushes are longer, right? Like on some systems, they can't really do that many shaders at once, right? So like swapping a shader is going to like flush out the pipe. So if you're naively like ping ponging like shaders every draw call or blend modes every draw call or something like that, you're basically kind of rapidly putting yourself into the worst case scenario sort of situation, right? Yeah. There are certain things that are relatively cheap, right? Like changing your constant buffer, like your shader parameters, right? That's going to be pretty cheap. Usually that ends up being cheaper than like switching your your attributes, right? What things are going into the draw call. Texture swaps are going to be relatively cheap. But yeah, those huge like shaders, blend modes, render target swaps, things like that end up being pretty costly.
Where did you develop the intuition of what's costly and what's not? Is it that you have a pretty good understanding of how the stuff works a layer lower, or is it just kind of like through hard-earned profiling and like all that stuff?
A little of both, for sure.
Yeah.
Like, I mean, it's probably a combination of GDC talks, slamming your head against the wall, doing your own profiling, and then reading kind of papers on how the hardware works and understanding that a bit more, and then kind of all that stuff like circling around and feeding in on itself so that you kind of start understanding things from different angles.
Yeah.
But sometimes you encounter some hardware where you're like, that doesn't make any sense, right? Like it's some new, like they're doing something different, or the hardware's a little bit different, or the driver's a little different.
So that must be one of the challenging things, is that like what is fast on one piece of hardware might not be fast at all on a different piece of hardware, right?
Yeah, I mean, basically that's why developing for Android is like the worst thing.
Because it can vary from device to device, even though you're on the same OS, right?
Yeah, like, so, I mean, it's like, well, and I mean, it's exacerbated, right? Like, there are different versions of Android, right? Some written by not Google, right? Like they use the base, right? But Samsung's going to go in and do some weird thing. Like Motorola is going to do some other weird thing.
Right.
On top of that, there's way more GPU manufacturers that are going to be used on Android than like PC, right? PC, you got, AMD, Intel, NVIDIA, right?
Right.
I'm sure there are some other ones out there, but like not really of consequence. But there's a,
Wait, what other PC GPU manufacturers are there?
I think there are some random ones out there, like probably a couple, unique to your country ones and things like that.
I see.
Let's say at the beginning of this, something reminded me to look up what the graphics card in my old iMac was, and it was the 3DFX Voodoo 2, which that company definitely doesn't exist anymore at all.
Yeah. Yeah, they got pilfered for parts by NVIDIA.
Mm-hmm.
So yeah, it's really hard on Android because of that. And it's just fragmented. And just a bunch of different GPUs. Sometimes like a phone, like the name of a phone will have a different GPU in like Europe than it does in the US, even though the phone is the same name. But yeah, so I digress. It's terrible. But yeah, generally those principles are going to be roughly the same, right? What order you're going to do things on, but you'll get some different nuances, like some GPU, especially back when more GPUs would do vertex programs and fragment programs. Did we lose Jeff?
I think we lost Jeff.
5 minutes later.
Oh, I see Jeff.
There he is.
Welcome back.
He made it back.
Hey guys.
Hey.
What are you doing?
Where you been?
What's going on? What's going on tonight?
Oh,
What do you got going on?
Nothing much. So you and Steve have swapped head positions, thanks to Twitch.
That's fine. It's not the Steve and Dom show.
It's
the
fine.
Steve and Dom show featuring Jeff. It has a better ring to it, wouldn't you say?
Absolutely. We got to switch domain names, though.
Oh, yeah. Oh, man.
Sorry.
I had the actual crash report sitting on my end, but it went away.
Sorry, you got your software update.
It was actually, we were talking about graphics, and I think the graphics card caught on to us. We were just like slinging shade at like how hard it is to write programs for graphics hardware.
Oh, wow. That's what we get for disparaging.
And my graphics driver crashed. Yeah.
And why did I lose my virtual background? Man, something is just... All right. Fine.
That's okay. Everybody knows you own a Uke now. I think that's basic.
I love that little uke. Made in Berkeley.
No kidding.
Yeah.
Where did they make it?
Right next to Berkeley Bowl. There's a little music store that makes ukes.
No way.
It's good.
I gotta get one of those ukes. I want a Berkeley made uke.
It's worth it. Yeah.
Steve, do you play any instruments?
Not really, no. I played saxophone way back in the day.
You play the saxophone?
Yeah.
That's dope.
That's awesome.
But I have not touched it in double-digit number of years. I'm sure like 20 something.
So you still own your saxophone? Is that what you're saying?
I'm pretty sure that it is around here somewhere.
Oh, that's awesome.
It's probably in horrible condition.
I've got an alto in a closet, I think, in my parents' home.
Wait, Dom, your dad's a saxophone
My dad's
player,
a saxophone player, which made me far too intimidated to ever actually try to play the saxophone for real.
But he tried, right? He tried to get you to play, I'm sure.
No, my parents never really pressured me. They offered all things. They were like, "Here's an extra saxophone," but it was very low pressure. And like, I was always a computer kid. I fixed their music programs and their art programs, so we sort of figured out our balance very early on.
Soon you will fix their 3D renderers.
Oh man,
Soon.
I can't wait till my parents write a 3D render. That would actually be extremely cool, and I would love to debug it with them.
Yeah. Yeah. So my graphics driver crashed. First time for everything. I'm glad it happened amongst friends.
Yeah.
You know what I mean?
Yeah.
I don't even remember what we were talking about. What were we doing?
So I think right when you froze, you were talking about.
Did I freeze?
Performance.
Did I freeze? At least freeze with a good expression on my face, because that's all.
It wasn't terrible. It looked like you were very deep in thought as you were talking about. Yeah. So we were basically talking about the order in which you draw things, right?
Yes. Yeah.
And performance requirements there. I was talking to Dom after you dropped off of. It tends to be kind of the same order-ish for a lot of GPUs, but you're going to end up with different things that are costly depending on the implementation, right? Something might just be really slow at reading textures,
Sure.
or have a small number of parts on the chip that can do pixel shaders or something like that, right? So if you're trying to do anything horribly complicated there, it'll end up being slow. So there's a lot of nuance there, but kind of the general rules do apply, but you might shift things around if you like run into some troublesome device, Android device. You're like, why is this one slow? Make the pixel program like a lot simpler. And it's like, is it way faster now? No. Okay, let me reduce the verts. Is it way faster now? No. Okay. That sort of thing.
So one of the things that you sort of mentioned early on is that it sounded like if you had to be worried about one thing to reduce, it sounded like the draw calls was the major thing, right?
Oh yeah, like basically, especially on a modern GPU, you can have pretty complicated shaders, a lot of triangles, and if you just throw a bunch of it at the GPU at once in like one draw call or a couple draw calls, like that individual complexity, because it's so fast and it's just like pipelining everything, it's going to chew through a lot of stuff, right? But if you're dicing it up and you're like, here's a little bit, like here's a little bit, here's a little bit, you're not getting that like massive throughput, right? You're probably using very little of the GPU at that point.
Yeah.
Because even like if you render like a little tiny triangle like by itself, you're probably wasting you're using like a 64th of the throughput on like one of the execution cores, right? Because it's just like I did like 4 pixels and I couldn't use any of the other threads on that chip.
Gotcha.
So just like hammer it hard with a bunch of stuff in a small number of calls, and it should do pretty well.
So for us, like we're doing draw triangles once per like individual model on our screen, actually, right?
Once per mesh, actually. So the tank is like 7 or 8 meshes, right?
Oh.
Yeah.
Oh, I see.
So it kind of raises the question. This is why I kind of booted up the shader. I think I know where you're getting at, Tom, which is that the way that we've structured, like for example, the vertex shader, it's the way that like pretty much like all the tutorials tell you to do it. And so, in particular, the model to world transform is a uniform. So I'm guessing that if your uniform changes, you need a new draw call, right? Is that a fair assessment to make?
Yeah.
Although there are things called uniform buffers, which we haven't gotten into.
Right. Well, okay. So yeah, there's hardware instancing, right?
Okay.
So
what does that mean?
it's basically a way of packing more draw calls in, right? So like the simplest version is like I have a cube. I want to draw 200 of them.
Yeah.
You don't do like
200
draw elements like 200 times. You do I forget in OpenGL what it's called, like draw element array or something like that.
Draw arrays, I think is the WebGL version of that.
Yeah, something along those lines, right? And you, I'm trying to remember. I think you basically do like your uniform will have 200, matrices in it, right?
Yeah.
And you can set up how different parameters repeat during the draws. So when it switches to the next index of the draw, like, is it repeating this one over and over and over again, or is it switching like down the line? And that's how you do that, right? So like your trees or something like that, you could potentially do that way, right? Where all your trees are one draw call. And that would end up being a lot faster, probably especially because you're, in whatever JavaScript land is happening.
Yeah, totally. Because God knows what is happening on the JavaScript side of in each one of these draw calls, right?
Right. Like, is it, creating a bunch of JavaScript objects and storing a bunch of things and copying it around and all that stuff? And can you do that faster if you just slam it with one?
Dom, I'm thinking from the perspective of the way this render manager is set up, it almost seems like each one of these draw stages could be a single draw call, right? Because the shader is the same the entire time, right?
Yeah, I feel like one draw call per shader, if we can help it, feels like a good thing to optimize towards.
Yeah, as long as we are arranging we'd have to figure out, like, I guess the alignment of the attribute buffers and how they align with the uniform buffers is since I don't know what a uniform buffer, I've like seen the word in the documentation, so I don't know how it's actually structured. Like making sure that those change at the same time, right? Because you like for a particular model or mesh, you have a particular size array of vertex attributes, and you want the uniforms for that particular instance of that mesh to change when the mesh completely changes or the instance of the mesh changes or whatever, right? And so making sure that those things are aligned are probably things. But it sounds like what we could do is basically per shader, because the shader only gets rendered once per frame. We could have one draw call, right?
Well, and the notion of feeding in our like tank vertices and normals and a uniform buffer all the positions that it should show up on the screen, or the trees instead. Like, one call to render however many of those objects versus like having to refill that buffer and change the uniform every time.
Yeah.
Honestly, I'm amazed for all the work we're doing that it's not slower.
Well, I mean, the thing to say, like, it's hard to tell looking at this.
Yeah.
But like, I don't imagine you're kind of in the realm of like, that many batches, right?
I don't necessarily think we're in the red zone,
right? Hundreds should be fine. It's when you start to get into thousands, hundreds to thousands, obviously depending on the driver and all that, that you would run into trouble. But modern computers are pretty fast. You can brute force simple things pretty easily,
and
right?
Like our mesh size is like, our meshes are in the kilobyte range, and I know like my graphics card is like, I've got the unified memory thing, which is weird, but like Jeff at least has 500 to 2 gigabytes of graphics memory on this machine. Like, I'm sure we haven't even touched it.
What I did touch is whatever thing causes it to crash. I don't know what it was.
Fair.
Yeah. So cool. That's already like, I think, pretty awesome and enlightening, I think.
That gives me a lot of food for thought. Should we move on to our second question?
Yes. Are you talking about like wireframe rendering?
Yeah.
That particular subject.
Yeah.
So what are we doing with wireframe rendering, Dom?
Well, we have a general thought around an aesthetic for this game. And I think maybe it's definitely in our mind because it's something that we can sort of do programmatically too. Or we hope. But we've been looking at like Battlezone or Spectre as like the classic. Yeah,
Okay.
that gorgeous sucker. We'd love to like take a mesh and spit that out.
Spectre game.
Spectre, you're gonna get the James Bond movie otherwise.
I'm still gonna get the James Bond movie. Yeah. So I guess basically like
maybe that. Yeah. Even
Dom and I have no artistic integrity really, or maybe at least he does, but I don't. And the average of that is that like what we can lean on aesthetically is just pure nostalgia, right?
Okay. I mean, basically, you're going for your Zoom background.
Exactly. Yeah. You're not the first person that said that, but basically, yes. The sort of currently in vogue, but maybe rapidly going out of style synthwave aesthetic.
Never out of style.
Never out of style. I'm glad that you think that. What it is that I don't know. Bunny and I were talking about recently that I guess Bob Dylan sold his catalog or half his catalog very recently, which is kind of like a weird thing for Bob Dylan to do, right? He's like probably like 70 or 80 years old now, and like why cash in now? And it kind of occurred to me that like he is probably at or beyond or like slightly beyond his peak of financial viability. Right. I'm not trying to make an aesthetic judgment on Bob Dylan here, but like, when do you think Bob Dylan's music is the most valuable? Now or in a year or in 2 years? It's probably now, right? Like the boomer generation. What's that?
Probably.
Yeah.
Like, audience is going to get smaller every year.
Exactly, because it's boomers, right?
Yeah.
And so basically the synthwave aesthetic is our Bob Dylan, right? I think we're all roughly in the same kind of like 5-year span for birth dates, right?
Bob Dylan. So I'm just writing that down so that can be the title of the stream later.
Okay. And like Cyberpunk. I mean, how many Cyberpunk games are being released this year, or in the last 6 to 8 months?
At least
not
2078. Yeah.
Yeah, exactly. At least 2,777 plus one. But we've had the idea for this for a long, long time now. So in particular, for wireframe shading, Dom, is it okay if I run the other program that we've been working with?
Yeah.
The X-Wing demo. We'll see how well it will run here.
Totally. And 3D HTML in here should also be running the shader thing we tried.
Oh, yes. Oh, okay. Yeah. How do I open that? Is it just... Actually, I can do it from here, right?
It's somewhere in Finder, yeah. Let me see.
Open source tools, scratch pads, 3D.html.
Yeah.
Oh, that didn't do what I expected it to do. Well, at any rate, like what we're going for. Let me load the other thing as well, just so we have a couple different things to mess with here. And let me fire up a terminal. We're just jumping across desktops. Sorry about that, guys.
Careful, you're gonna throw just way too much.
I'm gonna crash my
card.
game.
Yeah.
I'm just gonna crash. Yeah. Too many draw calls.
3 WebGL context? No, thank you. Man, my cats have been having a freaking party behind me all stream long. It is wild. I don't know what's going on, but they stole my hat. They ate a book. It's been a little distracting. Come here. Or not. Parse.
What do I do if parse is not found?
Oh, I mean, it shouldn't be. It should be in your npm executables. So like npx parcel, yeah.
Gosh. Oh, JavaScript. What a shit show. But it's our shit show, right?
As I say, yeah, it's bless this mess.
Yeah.
It's fine.
I should move this over to ES build. So we moved from like, this is us dweebing out about like web front end technology changes, but like we went from one bundler package to another, and it was literally like it sped things up by 300 times. Like rarely do you ever get an optimization that it's like
actually 300 times.
Actually, literally, actually 300 times. And when I say literally, I literally mean literally.
Yeah, our builds went from like 15 seconds to 1/10 of a second somehow.
Yeah. Okay, so this is a thing that I made a long, long time ago because I was trying to like just play with an idea. And so basically this idea for this aesthetic, something that Dom was really into, but also something that I had in the back of my mind. The idea here is essentially we just have wireframes of 3D objects with, it's not just like triangles being drawn, right? It's not like, and in fact, the reason why Dom mentions this this particular demo is that what's going on in this this here is that we are drawing the edges or sort of the outlines of the triangles in the fragment shader. And the way that we're doing that, let me just bring up the code. The way that we're doing that.
As I say, 3D.html is just like the most descriptive name I could have given this.
Yes.
Sorry about that.
Spinning cubes.html. Yeah. It's like askcam.dll. It's just like very, very self-descriptive. Sorry, I had to bring it up again. So the way that this works is okay. So first of all, like we've kind of like identified the problem of drawing wireframes for models, basically amounting to two things. One is, how do you draw lines in the first place when a lot of the way that the 3D graphics pipeline seems to be set up is to draw like fully shaded faces of triangles. How do you draw lines, A? And then B, how do you eliminate common edges on the same surface, on like the same like flat surface, right? If I think sort of the aesthetic that we're going for, if we were to draw a cube, for example, would be one that didn't have these diagonal lines on them. So I think it's similar to the polygons that are being drawn here, right? These like pentagon faces are actually what, 3 triangles? Did I count correctly? It's probably 3 triangles, but they don't have any of the intervening edges drawn there. And so I guess, Steve, the overall thing that we wanted to talk to you about was what are ways in which we could go about doing this. And we've thought of a couple different ways that we can try to explain to you right now, and there are different trade-offs. How's that sound?
That sounds good.
Cool.
You can jump in with your stuff, since I haven't done crazy amounts of this aesthetic, but I imagine if you have multiple ways of doing it, I would have an opinion on them.
Yeah, sure. And just so you know, when we Googled on how to do this, we didn't actually get how to do this, but we did see like a lot of demos of like Maya and 3ds Studio Max, where they like literally just like pick a material and it just like boom shows this particular aesthetic.
And as Dean pointed out in chat, he was like, "Oh, 3JS has a wireframe shader." And I'm like, "I know."
Yeah, well, we actually looked at the 3JS. 3JS is like the most popular game engine in the world, is it not? I think. No, I'm actually not even kidding. I think it might actually be at this point, just because it's like the 3D game engine that everybody uses for browser programs, right?
I mean, I've heard of it, so yeah. I mean,
there you go. That's not
there, right?
The thing about 3JS's wireframe shader is it works a little bit like this one does, and so we'll get into like what it's actually doing. So for this cube thing, this is, I think, like this is us taking a mesh that is just a normal cube mesh, and then trying to draw edges purely inside the fragment shader. I say purely in scare quotes because we weren't 100% able to get there without at least a little bit of augmentation of the vertex data. And in particular, what we did is we added a barycentric coordinate to every vertex. The barycentric coordinate is 1, 0, 0 for one of the vertices of a triangle. It is 0, 1, 0 for the next one, and it is 0, 0, 1 for the one following that. And it doesn't matter how you order those on, according to like which vertex on the triangle. It doesn't really matter what we do, as long as they are each different, right? And what we're basically doing is we're just allowing the vertex shader to pass this barycentric coordinate value through to the fragment shader. There's no transformation in the vertex shader, but we're going to get it interpolated on the pixel, on like the individual fragments of the triangle. And basically what we're saying is that if any of the values of barycentric coordinate, so either the x component, y component, or z component of the barycentric attribute are basically close to 0, what that means is we're really far from one of the vertices, right? And so it's essentially like if that value is less than a certain threshold, we'll say draw the pixel. Otherwise, we'll say drop the pixel, like draw it with 0 alpha or something like that, right?
Right. Yep.
There is a technique to use screen space partial derivatives to make sure that these lines are consistently thick, regardless of how far the geometry is from the camera. We didn't quite grok that. You can watch our previous streams watching us staring slack-jawed at the screen, trying to figure out the math for the f width fragment shader function, and we were just kind of it probably just works. On top of that, there are ways to use sigmoid functions to anti-alias these lines a little bit better in the fragment shader. Right now, there's not really any anti-aliasing going on right now. It's either one color or another, right? There's no intermediate. Those two things we're not super interested in. I don't care about. Well, it's just that they're details. There's stuff out there that tells you how to do it.
Yeah.
So this technique almost it's 90% of the way there of just being purely in the fragment shader. Didn't have to invent a different mesh or anything like that. We did have to add this barycentric coordinate notion because we didn't know how else to say how do we measure how close to an edge of the triangle we are, right? The only way that we could do that is just add an attribute. It does kind of feel like this value should just be available ambiently in the fragment shader somewhere because it seems like the fragment shader knows, or at least something new, because it was interpolating the attribute values by the time you got to the fragment shader, right? So you think can I have the multipliers, please?
Yeah, there are some kind of intrinsic things in fragment shaders. I don't think that's one of them.
Right.
It might be, in which case you could use it. Letting inputs from the vert shader interpolate across and used in the pixel shader is basically all the fancy graphics programming stuff, right? You're just slam it in the vertex shader, maybe we'll do some math.
Right.
If I can do it in the vertex shader, that's awesome because now it's just interpolating in the fixed function hardware, and that's gonna be way faster again because it's not programmable, it's nothing special. So
yeah,
that part of the technique seems totally sound. Obviously, if you had something intrinsic in the shader to do that, you would do that, right? Kind of like how the derivatives get passed through, and you can sample that, right?
Yeah. Now, there's a couple problems with this solution. The first is that it turns out that adding the barycentric coordinate in the right way is tricky. Now, if we didn't use index buffers for our vertices, and we just had literally one unique vertex attribute per vertex of every triangle, right? Then it would be easy to add these in there. But because the same vertex is being reused multiple times for different triangles, it's kind of hard to figure out what value you're supposed to assign, right? Like I said, the ordering doesn't matter per triangle, but they do need to be unique per triangle. And it's actually kind of like an interesting computer science problem. It's it feels okay, this is an interview to go work at Google or something like that, right? It's kind of how, especially if you had a face where the same vertex was shared across more than two triangles, right? Imagine you had some complex polygon, So that's problem number one with this approach, is that kind of coming up with this and still wanting to use index buffers is a little bit challenging. The second thing is that we didn't know how to do common edge removal purely in the fragment shader. Because I don't think in the fragment shader you know anything about your neighboring triangles at all, right? It's not you don't know anything. You don't even know that there's another triangle next to you. Is that correct? Yeah.
We were really hoping that we could look at the normal value changing, and it just turns out totally impossible.
Yeah.
Apparently this is what a geometry shader is for, which does not exist.
Oh, really? WebGL doesn't have them?
WebGL does not have a geometry shader. Yes.
That's unfortunate.
Yeah, so we googled all this stuff. Basically, people were like, "Okay, well, you can use the geometry shader," and I was like, "Fuck you! I won't do what you tell me." You know, because we don't have one, unfortunately. I think furthermore, people were like, "Oh, don't use the geometry shader because it's slow." And of course, when any random internet programmer says that, you don't do it, right?
Yeah, I mean, they're not wrong. But so for a triangle wireframe, heavily wireframed aesthetic,
Yeah,
your number of triangles will probably be relatively low.
relatively low. Yes.
Which tends to also be where geometry shaders probably don't cost that much because they're not that much stuff.
Yes.
That is also where you could be like, screw it, every triangle is just 3 unique verts.
Yep.
I don't care. I'm just going to pre-process all my models to bust out the tries so I can get those coordinates. And now it's super easy because it's just, 0, 1, 2, 0, 1, 2, 0, 1, 2 of those values, right?
Yep.
And now you're getting a perfectly sensible mesh. And if you want chunky wireframe, it's not going to break the bank. Like, that's fine.
Yeah. Totally. So that was this technique. And we felt like we kind of bumped into we can say, okay, you know what? If assignment of the barycentric coordinate is a complex computer science problem, let's just cut the Gordian knot and just screw the index buffer. We're just going to have we're just expand all the triangles into their own individual things. And then it's really easy to do the assignment. But then we run into the other hard barrier of WebGL not having a geometry shader, right? So it kind of makes it a non-starter at this point.
You were saying that if you were able to use the derivatives that you maybe could get, other than you also want to eliminate lines, right? Is that
we want to eliminate the common edges, right? So that was the other thing that we were running into.
Right. Do you want the common edges ever changing based on anything, right? Is that also a pre-processable step?
It is, right. So one of the things that we had thought about was we said, okay, what if we don't have that version of this code here, but we did work on it a little bit in this. It's what if we said, if an edge should be eliminated, we'll have a vertex attributes that's totally scalar. It's just literally one value on every vertex, which basically says if the vertex or actually, Dom, I think remind me if I'm just correct me if I'm wrong. I think what we did is we said if we want to draw the edge, we'll set the attribute to 1 on both of the surrounding vertices.
I think that's correct. Yeah. I thought we set it to 1 when we set it to 1 on the surrounding vertices when we didn't want to draw it.
When we didn't want to draw, right? Because then that value, that attribute would be 1 along that entire edge.
Yeah, and the problem is that it cut the corner out.
Yeah, it actually removes the corner itself. Yeah.
Which,
Yeah.
Yeah, I mean, I'm trying to think if there's a clever way to futz with that.
Right.
Is there might be something you can do with 3 values per vert. So it's giving you edge information almost about your lerp.
Yeah, there's some encoding of information in there that could. I'm not 100% sure. Right, somehow you could. Yeah, maybe the three value version would be okay, well, it'll tell you if you happen to be on at least a line that we do want to draw. So even if you are on the line that we don't want to draw, but you are on the line that we do want to draw, we'll draw you, right? Something like that, right?
The edges draw to the left, draw the corner, and draw to the right. You can talk about the edge and the intersection, basically.
Well, it's almost if it's the barycentric coordinates, if you're then doing a 90-degree rotation of it, right? Almost to say, am I trying to eliminate the edge or not? And if I'm trying to eliminate it on both sides, would that work? Would you have enough there, or do you need to add more? Probably have to like bust out a piece of paper to figure out if that's even
totally.
possible.
But I know what you're getting at. Like basically, there's probably a way to arrange the calculations so that maybe you could say like, well, if 2 out of the 3 of the components of this attribute are 0, then don't draw it, or something like that.
Yeah.
So here's the thing though, is like if we're going to bother pre-processing the geometry, why don't we just create another mesh and make it a bunch of lines, which is what this technique is, right? So what I'm doing here is there's 2 render passes. One of the render passes basically it doesn't write to the color buffer, it just writes to Z, just so we can eliminate like pixels that are drawn behind the faces.
Okay.
And then basically this pre-processes the mesh using whatever technique we were going to use before to find common edges. The common edge algorithm here is basically, it says, we'll basically pair up triangles based on whether or not they share two vertex positions. And it's a very naive thing, which like loop over all the triangles and say like, do they share two vertices? And if they do, we compare the normals of those triangles. And if the normals between them, I forget, I don't remember if I'm dotting them or crossing them or whatever like that. Like if they are roughly pointing in the same direction and they share an edge, then that is a common edge, right? And then we can do something to that. Once we've gotten into that situation, we do something to mark that edge. And in this case, what we do is we just fail to emit a pair of vertices in our line mesh, right? So what's going on here is that like we essentially have 2 different meshes for every one of these objects. One is the full triangle meshes that form the faces, so we can like basically draw to the Z buffer so that nothing behind them draws through. And then we have a second mesh that is based on the same geometry but derived from, but it's a derivation of that is just the lines. If you look at what the 3.js line shader is actually doing under the hood, they actually have basically a bunch of lines as well. So okay. I thought they knew something that we didn't. Then when I looked at their code, I was like, dang. Yeah.
Yeah, I mean, doing that pre-process step would be pretty easy, right?
Yeah.
Like, yeah, you're right. You just dot product that, right? If it's, I don't know, above like 0.9 or something, so it's generally in the same direction, then you throw it out.
Yeah. Yeah. I also think if you cross them, it would be 0. It would be close to 0, right? If they're both pointing in the same direction.
If they're like literally pointing in the same direction, you'll get like 1, right? They're perpendicular, you get 0, and then if they're opposite, you get -1 on a dot product.
On top, yeah, I was saying if you cross them though, then if they're pointing in the same direction, then it's going to be close to 0, right?
Right.
Although I don't know if cross product has like the continuous property where like if they're like roughly in the same direction, you'll be like closer to 0 than not. I'm not sure exactly how that works. I think it is actually though, right?
So,
at least in 2 dimensions, the cross product is like the area of the parallelogram, right? Fuck, I'm just like I don't remember this.
I mean, I would for sure use dot product for this.
Yeah.
100%. So.
Okay, cool. Right. Like, yeah, you basically normalize you make the normals units and then dot them and see how close to 1 you are. And if they're roughly close to 1, then they're basically coplanar, right?
Right.
So yeah, those are the kind of techniques that we've been juggling, right? Like, and
I mean, there's definitely pros and cons, right?
Yeah.
The pre-process means you can't do anything really dynamically anymore, right? If you want to start animating and having the same aesthetic and it's a skinned object or something, and now faces are switching from shared and should be flat to not, kind of more akin to like a tune shader. Then that's going to be a bit different. But if you're like, yeah, it's an old school aesthetic, and we're basically always going to want the same lines to be drawn for the wireframe.
That is super interesting. Because I never even thought about animation, where essentially what we're saying is that whether or not like faces or coplanar can change over time, right?
Right.
That is
like it might look weird in a wireframe aesthetic and fine in a tune aesthetic, right? Like because it might look weird, like you have something and then it bends and all of a sudden the wireframe pops in. Like you might just want that line the whole time, but I would imagine the pre-process would probably be fine for any of your aesthetic choices.
Right. So here's the thing: is there a holy grail solution to what we're trying to do, where we could avoid pre-processing? It seems hard, or at least like when we say pre-processing, I mean we could do it right before we draw, right? We could basically just like scan, like we could just animate the mesh in CPU, and then figure out all the coplanar stuff. But that seems kind of costly, right? Oh, I guess it kind of depends on the size of the geometry, but in general, it doesn't seem like a super scalable solution, right?
Yeah, I think you're right. Size of the geometry, like number of things you're doing for it. So yeah, definitely possible. I mean, CPU skinning was a thing for a long time, and that, depending on how complicated your line detection is,
what does CPU skinning mean?
So GPU skinning, you're going to basically send the matrix data over to the GPU along with some basically bone weights, so that it can do all the transformations of the verts and the blending between different bone weights all on the GPU.
Right.
Versus pre-calculating that on the CPU and then basically mapping that buffer over and drawing it.
That's interesting. Is there anything about the OpenGL API that exposes that functionality to us, or is it just kind of like expressed as a vertex shader?
The skinning?
Yeah.
Yeah, that's just shaders.
Okay. Because one question I had in my mind. Sorry, we're going back in time.
Take us back.
We basically are doing animation by, once again, we're sort of like passing down transformation matrices through the hierarchy of meshes in a particular model. And, when we want to do mutation of those things, we'll pass in like this modifier value, which is like essentially the thing that's spinning the tank turret, right? We even kind of divided it into like a pre-multiply versus a post-multiply because we didn't know which one we wanted, so we added both. Do these multiplications for matrices have to happen on the CPU? Because they currently are. Just because that was the only way we knew how. But it sounds like there is some way of doing essentially hierarchical matrix multiplication to an arbitrary degree on the GPU, because that's what it sounds like you're describing with GPU skinning, right?
It's not an arbitrary depth, though, right?
Is it a fixed depth for GPU skinning?
Yeah, so I mean, basically you have a certain number of bones that any vert can be applied to, right?
Right.
And that's kind of the number of matrices that you're going to multiply it with. So it's not just like, traverse the hierarchy and figure it out. You're that part you're kind of pre-processing on the CPU, right? Where all the bones are and their transformation data.
Mm-hmm. So I like knowing
if you actually have a hierarchy depth, then you could potentially just be like, well, we're just updating which matrix is going to be multiplied and multiplying it in the shader. But probably not going to get that much of a win there if you're already having to copy the data over anyway.
Right. Okay. Well, I think that sounds like a pretty deep subject, but I'm kind of interested in it because I like just seeing all these matrix multiplications here happening like on the render side. Like we could cache over this. It sounds like a hard problem, but like that would be one way to speed it up. But it just seems like I wish I could have another computer doing this stuff, this math. And it would be interesting to see if I could figure out a way to defer it to the GPU if possible.
So I mean, I guess if you're, I think.
What was OpenGL doing when we were pushing and popping matrices? Was it multiplying those on the CPU, or was it allowing the GPU to do some of that stuff?
It's going to do that on the CPU.
Okay. All right. So it's doing what we're doing here. Yeah.
Yeah.
Yeah. Okay.
Which I mean, like, it's going to be fast enough. Well, JavaScript notwithstanding, it should be fast enough, right?
Yeah.
Like, you don't have that much going on. Again, if you're parenting a lot of stuff, it gets crazy. If what you're doing right now doesn't really require too much, like I could see even doing that as almost just effectively, if you wrote a skeletal system, you could be like, yeah, just take this bone and rotate it. It's just in an array of matrices that individual verts are choosing which ones to apply or not. That you could push off to the GPU.
Right.
Interesting. I feel like we kind of backed into that through a different setup.
Yeah.
That wouldn't be that hard.
Yeah. On the plus side of that, now it's actually like, then assuming you're not swapping textures and a bunch of other stuff, like now it becomes one draw call again, right? Instead of 7, whatever your tank is made up of.
Right. Right.
That stuff is probably going to be like a little bit of a rabbit hole to go down where you're, learning all this transform stuff for a while. Just, it's probably going to be more educational than beneficial to your game for the complexity you have, but
right.
It certainly would be an interesting exercise.
Right. Okay. So back to the whole like wireframe business, right? What I guess we're trying to think of is like, is there any other way of doing this that we haven't thought of?
It's like probably, but I think they'll all probably be variations on a theme, right?
Yeah. Yeah.
Like trying to, obviously there's, with a geometry shader, you're going to have a few more options there. But yeah, it's like, are you pre-processing those verts? Is it a multi-pass thing? Is it a pre-process thing? Or is it a fragment shader thing, right?
Yeah. So Steve, I remember like a couple of years ago, I was talking to Shane about this. So Dom, Steve and I have a mutual friend, Shane, who last I talked to was the engine programmer for Yacht Club Games, which is the company that did Shovel Knight. Is he still there? Like, I don't remember.
To my knowledge, I mean, he was there like at least, I don't know. Last time I visited Yacht Club, he was still there, which is, I don't know, years ago maybe.
Right.
Nice.
Are they still putting your face in games?
I think that died when most of the Yacht Club employees were like, "Who is this?"
Oh, okay. Yeah. Are you in Shovel Knight?
Was I in Shovel Knight? I think that's the one where they're like, "Yeah, we don't know him enough." So I think it died at Way Forward.
Oh, that's a bummer. There was a tradition at Way Forward where they would put Steve's foot, Steve's face, not his foot. But it was called the foot face because of the alliteration, and also because it was a retrograde workplace culture where everybody called each other by their last name. So
Love it.
I was talking to Shane, and I told him about my like draw the lines on top of the Z buffer faces idea, which I was very proud of at the time. Now that I've been like talking with Dom about this idea, now it just seems kind of rudimentary and basic. But at the time I was like, I told him about my idea, and like he was kind of like, yeah, cool. And so then he went on to Shader Toy, and he cooked something up that I think worked. It didn't 100% work because he had like really thick edges in some places, but it seemed like it would have been tunable, and I think he was able to do the common edge elimination, but I'm not able to find a link to that Shader Toy link anymore because we were talking on a Slack channel, which has long since evacuated the chat history, and also I have a hard time getting hold of Shane. He's a hard person to get hold of.
Yeah, I imagine I'll probably do the exact same thing Shane did, where it's like, ponder, and then like you leave and you go do a bunch of research for no apparent reason, and you're like, oh, I wrote this crazy line shader thing.
Yeah. Well, if you figure it out,
next time we'll have to do like the pre-seed, you're like wireframes, and then I'll just like do the research ahead of time and come in and look super smart.
Yeah, no, we wanted you to come in cold so the conversation was fresh and invigorating. However, we're in graphics land right now, and you are a self-professed graphics enthusiast, so we might be bringing you on more for this type of thing.
Yeah, I think that'd be cool to do, especially if you're trying other things. The thing I would probably go down is I would start to explore is there additional stuff I can encode? I would just have to sit down and think with that, or like pull up some papers and be like, is there a way to give like that clean, crisp line, especially if you're changing the size depending on distance or trying to keep it consistent size?
Right.
I think there's probably a clever way to do that without the pre-processing to get the look that you're kind of showing.
Yeah.
But that I would like sit down and do the shader for.
I've seen some wireframe materials, at least screenshots of wireframe materials in like Maya or whatever, and they not only do what we're looking at right now, but they also do something really dope, which is that like their quads didn't have straight edges, right? They would like subdivide the surface of a mesh into quads, but they wouldn't have straight edges. Like you'd have curved edges, you know? So I was like, oh man, that's pretty dope. So clearly there's a lot of unexplored territory, right? And even if they had a geometry shader, it doesn't matter. Like it's still like someone had to figure that out, right?
Do you think there's any like authoring you'd want to do on the lines, like different colors for different parts of the object, or?
Yeah. You raise an excellent question, because we haven't even talked about like how we want to author this stuff. I think we would like to have the option of doing different colors, things of that nature. We may be going back to vertex colors. We actually had a version of these shaders that use vertex colors. It doesn't seem like a common thing that you can do in Blender or any of these programs. It seems like everyone's mostly pretty texture focused.
You can do vertex colors in Blender.
You can. Okay. We just didn't find that menu. We haven't watched any of the Blender tutorial videos because we're still too busy trying to figure out our asses from holes in the ground.
But we've got a rudimentary Blender pipeline going for these models, which is like a good
it's like
start.
Exports to GLTF.
Yeah,
it's pretty good.
I actually like Blender now. Like I tried to use it a good number of years back, and just like, granted, I didn't try that hard, but it was so different than anything out there that it's just like slamming your head against the wall a little bit. And then they redid their UI, and everyone's like, hey, like especially in my work, they're like, hey, everyone says that Blender 2.8, it changes everything. Like they redid all their UIs and now it's really good. And hey, here's this make a donut tutorial. And I went through it and I was like, yeah, this is actually a really solid program now. It's actually pretty enjoyable to use and it's free. It's pretty good.
Can't beat that. It's been nice. I think we had to figure out like how to deal with orientation, because it like had, Steve, I'd asked you in chat a few weeks ago, like, what's the right way to do orientation for these models? And you're like, too bad, sucker. There is no right way. But their export to GLTF does the right thing, because GLTF stipulates a particular orientation for models.
Right, which is really what you want. Like, I think FBX has, like, that's one of the things in the parameters, like which direction is like up and what coordinate system are you using, and
Yeah.
if the exporter author's like not actually paying attention to that and just jamming stuff in there, you're just like get garbage at the other side, right?
Yeah.
I will say I kind of enjoyed the good luck suckers freedom because I was just like, great, we can't do it wrong.
Yeah.
Yeah, I mean it's not too bad. Like I have a preference. I'm sure most people do. We're like, oh, this is kind of how I think. The weird thing is my preference somewhat changes depending on what game I'm making, right? Where you're like, if I'm making a top-down game, it's weird if one of those directions I'm predominantly moving on is Z.
Well, that's actually our situation right now. Is our 2D simulation is in X and Y because that's where it was when we were in 2D, and we didn't change any of that. And it produces some interesting artifacts, actually. Like rotations, we have to negate some of the orientations when we go into 3D because it changes when you're rotating like around the XZ plane as opposed to the YZ plane. So it's kind of funky. Yeah.
So it's like it's interesting how those choices change, right?
Yeah.
Where
doesn't the engine just basically stipulate a lot of this stuff for you though? Like if you're in Unity, do you have that kind of restriction placed on you?
Yeah, for sure.
Mm-hmm. Yeah.
So you just deal with it, right? Versus if you're writing your own engine, maybe you're like, well, let's just match the 3D software that our artists like. Or you're like, no, I absolutely have a preference. Like I'm making a top-down game and I want my gameplay to move around on X, Y. So Z is going to be up for any cool depth stuff, right? But if you're like, hey, you're way forward, right? And you're like, I'm making a side scroller and I'm adding 3D. Now it starts to get weird if Z is not like the additional depth here, right? And the gameplay's moving around on X, Y,
right.
Which is kind of where the differences come in, right? If you look at I think all of the Autodesk programs, because they started with like AutoCAD, right? They're a floor plan making company, right?
I've always wondered about that. Yeah.
And their ground plane is X, Y, right? Versus things that originated as like from kind of the video editing or whatever, where you're like X and Y are like pixels on the screen, and now we're adding something into this other dimension, which is not like depth into the screen, versus like looking at a table and thinking Z is like adding the model on top of your floor plan. So that's kind of where a lot of the differences stem from, is like what their use case was. And then it just, some people are like, well, our game engine uses stuff from Max and our game is that way, and just like scatters throughout the industry in weird, strange fashions. Like the default way things are stored kind of switches what default makes the most sense in OpenGL versus DirectX.
Right.
Things like that. So then you're like, oh, are you tailoring it to your graphics API or your 3D editor, or like whatever your brain thinks is right, and doing a bunch of flailing around to get it to do what you want it to, and just like doing a couple extra multiplies, and you're like, now it does what I want.
I don't know. Like it's kind of funny what you're supposed to optimize for, right? Because on the one hand, there's like kind of the mental model that you're optimizing for. Like you could make the argument that like for the tank game, X and Y should be the right dimensions, and just keep that consistent all the way down to the renderer. But it seems like, from my perspective, it's like you should optimize for whatever will make you less error prone in the areas where errors are costly, right? And I can just imagine just like if you treat X and Y as your ground plane, but you do need to make sure that your depth buffer is taking in like the right variable, right? Like you have to like flip coordinates at some point, right? And that seems to me to be like super, like, I don't know, maybe you write it once and you'd never touch it again.
Yeah, so that's probably what I would opt for. Is I'd be like, I'm gonna do it at the tail end of the pipeline, because I know that's a simple additional transform on your projection, right? Where you're like, all right, I'm just gonna do that. I'm gonna do that once. I'm gonna write it once. It happens every frame, and like hands off from there.
I guess maybe you can just build it into a matrix multiply somewhere, right?
Basically. So that's probably what I would do. I'm like, well, I want X, Y as my floor plane, so I'm going to treat every coordinate that way up until like basically the last minute where I have to swap it.
Interesting.
Proper.
Well, folks, it is 9:00 and a little after.
Nice. All right. Well,
goes
thank you,
fast.
Steve, again. Yeah, it goes really fast. It goes especially fast when we have Steve on.
Yeah.
You can treat that as a good thing or bad thing, Steve. We'll leave that up. We'll leave that one up to you. That's the kind of freedom you're afforded on the stream.
I'll take it as a good thing. And now I'm going to totally go look up wireframes and see what the state of the art is there.
Man.
Like, how does Blender do it? You know, theirs look pretty nice.
Yeah.
Ooh, sorry
It's
for
like I
nerd
use a
sniping.
geometry shader, right?
Yeah. It's open source. We can go find out.
Oh yeah, we totally could. Yes, that's how I figured out that 3JS they didn't have access to in Magic that we did not. That they were drawing extra lines. Actually, I think they were just doing quads. So they were doing something even more simplistic, which is, I think for every pair of triangles, they just assumed that they were adjacent and just like, anyways,
Oh.
like yeah.
Well, yeah, it's been a pleasure. I have a ton of stuff to research now, so great.
Well, yeah, hopefully it's useful, and maybe in the next week I'll end up slacking you some, or I guess discording you some links if I find anything good, because curiosity has been piqued. Because I've never, I can't say that I've had a wireframe use case too much not to this degree, right? Like if you write an editor, you're going to do a wireframe, but you don't. Like you just kind of show everything and move on with your life. Right?
Yes, and we are trying to make the Bob Dylan of the. What generation are we really? I feel like millennial is the wrong term. I've always felt that, right? Like millennial came
I'm
in.
a millennial.
Have you self-identified for a millennial since the origin of that term?
Yeah, it's always been my generation.
What year were you born again? 85? 86?
One of those is correct. Yeah.
Okay. So the distance between me and you is not that large, and yet at the same time we have this distinction here of like you adamantly being a millennial and me being trenchantly against the term. And yet at the same time we have nostalgia for the same shit.
You could be a Gen Xer. I'm like this close to Gen X.
I'm not. Yeah, I don't know. I'm not really Gen X. I feel like
have to
if
pick
you were a Gen
a
Xer, you would.
generation.
Like, yeah, I have to pick sides.
Yeah. The war is coming. Choose wisely.
Okay. Well, I think technically I'm a millennial. At any rate, the millennial's Bob Dylan is the synthwave aesthetic, and therefore we now have a use case for the wireframe aesthetic.
It's such a delightfully tortured metaphor. I really love it.
That's what I specialize in, really. What do I bring to what value do I bring to the stream other than that, really? Everything else is net negative.
Well, before I have to answer that question, Dean jumps in the last minute, bring back vector graphics. Oh man, that's a whole different thing, isn't it? Shit.
I mean, it kind of looks like this, right? The vector graphics look kind of like this.
Yeah, but that was like actually like 2D CPU rendering, right?
Well, I think what I think of when I see this aesthetic is the old Star Wars
SVG
arcade.
renderer. Oh no.
The Star Wars arcade game. Did you guys play that?
Yeah.
Oh yeah.
Definitely that aesthetic for sure.
Yeah,
I mean,
for sure.
especially since you have X-Wings flying around on your screen.
It does help that I have X-Wings here. That was just an accident. I got that from some other place. It wasn't cgtrader.com, but it was at least as disreputable.
You rebel stealing X-wings. You wouldn't download a car, would you?
A car?
Sorry.
Can you download a car? Like a 3D model of a car?
I think if you're a millennial, if you had the you wouldn't download a car commercial blasted into your TV for like 4 years.
Do you remember this, Steve? Do you know what he's talking about?
Yes.
Okay. Can you refresh my memory? It's probably in here somewhere. What was it?
It was like an anti-music piracy commercial that was like, you wouldn't steal a bike, you wouldn't download a car. And I'm like, yeah, fuck yeah, I would download a car. Like, what are you talking about? They're expensive. Of course I would.
And now you can, because you can 3D print a car.
Basically.
Yeah.
Excellent. Well, everyone, this has been great. Dean, thanks for hanging out the whole time, man. I feel
absolutely.
I feel like Dean might actually have to like come guest star on the stream too.
Dean should come on the stream.
Yeah.
He's making overtures. Like I think he's brought us the Lebowski references. He's talking about vector graphics.
Dude, what is this Vec 9?
He knows
thing just
3JS.
posted? Yeah.
I think he might know more than us at this point.
A lot of people know more than us.
This stream we should get some venture capital and make it the Steve and Dean show rather than the Jeff and Don show. And we can just be shadowy operators from behind the scenes.
Oh, man.
Executive producers.
Where the money's at.
Yeah. Dude, Vec 9 that he just linked in chat looks extremely freaking cool. Wow.
Vec 9.
It's like an actual CRT vector graphics game that was just released. Man, that is a throwback. Yeah.
I put it on the trailer.
Also solid communist aesthetic. Yeah. We should
Oh yeah, so they're even drawing like the cathode ray. Oh no, I thought they were at some point. You know, like kind of how like there's a little bit of decay on the line as well. We might not get that.
Oh,
we
I
might
think
not
they
get that
are.
far.
I think they are. I'm not even sure if this is a digital game or if you actually need to play it physically. And either way, I don't really care.
Yeah, see, this is fucking dope.
It's a real arcade game. Okay, yeah, that's the best.
Okay, yeah.
I look forward to seeing this at XOXO 2025 or whenever we get to go back to festivals.
Yeah, this is very reminiscent of the Star Wars. Yeah, okay. So now we have yet another thing that we don't know how to do, but that we want to do.
So that would be really cool. Like, I think they used to call it like an accumulation buffer back in the day. I think it was like built into the thing where it basically like store previous images so you could get like a crappy motion blur or whatever. So you get like that,
Yeah.
that hanging around of pixels for a few frames. You could probably do that just by, keeping some old frames around and re-rendering them into the buffer, like at a lower alpha. Be pretty cool.
Yeah, I had a buddy who did a game, like a mobile game that was like that, where he took the previous frame buffer and like essentially did like a jitter blur and like alphaed it into the current frame, so you would get the kind of like cool trails and stuff, that kind of thing. Boy, we need to end this stream. Let's get out of here.
Good night.
All right. It's a pleasure. See you guys later.
Thanks, Steve.
Yeah.
Bye.